Okay students, now I have connected R-2R DAC circuit. Okay, so this is the circuit diagram of R-2R DAC. Okay, as I explained on the whiteboard. So the same circuit I have connected here. Observe here, I am using this trainer kit. Okay, so to perform this experiment, that is R-2R DAC, you need to take the trainer kit. Okay, so on the trainer kit, breadboard will be present. Okay, so you need to choose the trainer kit having breadboard. Okay, so if breadboard is there, the connections will be easy for you. Okay, so on the breadboard, first you need to place MUA741 op amp. So I have placed MUA741 op amp here. Okay, from pin number 3 we need to connect R-2R ladder network. Okay, so you can observe here four resistors are there. So here there are four 10 kilo ohm resistors. So in parallel to that you have 2R. Okay, so this green color resistors, it represents 22 kilo ohm. Okay, so 22 kilo ohm resistors are connected, as well as R 10 kilo ohm are connected in series like this. On the breadboard you can observe. Okay, after this D0, D1, D2, D3. Okay, all the digital inputs are connected, must be connected to the toggle switches. Okay, so all these must be connected to the toggle switches. Here you can observe this is D0. Okay, D0 is connected to here inputs. Okay, on the trainer kit these are the inputs. Okay, so in this is D0. Okay, so I have connected from here to D0, and this is D1. Okay, and this is D2, and this is D3. Okay, so this is D0. Okay, D1, D2, D3, D0, D1, D2, D3. So I have connected the inputs to the toggle switches of the trainer kit. Okay, so then these two resistors must be grounded. So I have grounded the last two resistors. You can observe here, this is the common ground point. Okay, then pin number 2 of MUA741 should be directly grounded, should be directly shorted to the output. So you can observe here 2 is shorted with the pin number 6 in 6 of the op amp. Okay, so after that we need to provide plus 12 and minus 12 supply. Observe here, in the trainer kit only we have plus or minus 12 volts. Okay, we have plus or minus 12 volts. So this represents plus 12. Okay, this represents minus 12, and this represents 0. So here you can observe plus symbol is present here. Okay, so this is plus 12. Here minus is present, so this is minus 12, and here 0 is present, so this is the ground terminal. Okay, so don't confuse that green terminal is ground. Okay, so here the green one represents negative. Here you need to observe here. Okay, polarities of the supply. So connect the plus 12 volts to pin number 7. Okay, then minus 12 to pin number 4, and 0 to ground. Okay, so like this you need to connect the supply to the op amp. Then let us measure the output voltage. To measure the output voltage, you need to connect the output to the multimeter. Okay, so this is the multimeter. Positive probe of that you give it to pin number 6. Okay, so this is pin number 6, and negative terminal, that is black one, you connect to the ground terminal. Okay, common ground terminal. Now I will switch on the trainer kit. See, when you rig up the circuit, when you are still connecting the circuit, don't switch on the trainer kit. Once you completed the connections, switch on the trainer kit. Now you can observe here the trainer kit is on. Okay, so and this is the tabular column. Okay, so you need to tabulate the values here. Okay, so initially you need to provide the input with 0 0 0 0. So all the 4 bits must be 0, then 0 0 0 1 0 0 1 0, like that up to 15. Okay, when all are ones. So let us provide first initially with 0 0 0. So I have made all the 4 bits 0 0 0 0. Okay, so for 0 0 0, the corresponding output in the multimeter is 0 volts. You can observe here. Okay, so it is 0. So tabulate here, practical value, you tabulate it as 0 0.00. Next you apply 0 0 0 1. See, this is the LSB bit. Sorry, this is the LSB bit. This is the LSB bit, and these three this is the MSB bit. Okay, so this is D0. So D0 should be made high, whereas other 3 bits should be made 0. So for 0001, the corresponding output is 0.17. Okay, so tabulate that in the tabular column. Okay, 0.17 I have already tabulated. Now give the next input, that is 00102. Okay, binary 2 0010. For that you are getting 0.33. Tabulate that in the tabular column. Next you are getting 0100. So that for that you will get the value 0.62. Okay, next for 5 0101. For 5 you are getting 0.7. Okay, 79. Then 6 0110. For 6 you are getting 0.95. For 7 you are getting 1.11. For 8, that is MSB bit is 1, all the other 3 bits are 0. So 1000. For that the corresponding output is 1.20. Next 1001. 8, after 8 9. For 9 it is 1.37. Next 1010. 10. For 10 it is 1.53. For 11 1011 it is 1.69. For 12 1100. For 12 it is 1.82. Okay, for 13 1101. For 13 it is 1.99. For 14 14 is 1110. For 14 it is 2.15. And when all the bits are high, that is 15 1111, you are getting 2.31. So like this you need to tabulate all the values here in the experimental value column V0. Okay, at the same time initially you need to calculate the theoretical value. Okay, so how to calculate the theoretical value? Here I have already done the theoretical calculations. That is output voltage V out equals V reference into D0 by 16 plus D1 by 8 plus D2 by 4 plus D3 by 2. This is the formula of the output voltage. In this equation you need to substitute the inputs. Okay, initially for 0 0 all are zeros, all these terms become 0. So 0 into V reference is 5, so you will get 0 volts. Okay, for next case 0001. So for this LSB bit is 1, that is D0 is 1. So 1 over 16, remaining 3 bits are 0. So 1 over 16 into 5 you will get 0.3125. Next for 0010, that is D1 is 1. So D1 corresponds to here. Okay, so 1 over 8 and remaining all bits are 0. So 1 over 8 into 5 gives 0.625. So like this you need to calculate the theoretical values for all the inputs from 0 to 15. Okay, so like this I have calculated all the values initially. Okay, and I have tabulated in the tabular column. So now you need to observe both the theoretical value as well as experimental value. So first for 0 volts we are getting 0 0, but for second case, that is 0001, theoretical value is 0.62, but we are 0.31, but we are getting 0.17. Okay, so there will be a difference between. So for when all the inputs are high, theoretical value should be 4.68 and practical value we are getting is 2.31. Why this much difference here is, for 2R we are using 22K instead of 10K, so there will be much difference in the values, okay, experimental values. After this you need to measure the accuracy also. So accuracy is equal to the difference between the theoretical value and the experimental value. So this minus this, okay. So 0.31 minus 0.17 gives you 0.1425. Next 0.62 minus 0.33 gives you 0.295. Like that you need to calculate the difference of these two, which gives us the accurate values. Okay, so like this you need to tabulate the values in the tabular column. Okay, so this is the experiment. I will scan these values and send you the picture of this. Okay, tabulated values. You need to record this in the record book. Okay, you need to write this in the record book. Okay, so this completes R-2R DAC using op-amp and using toggle switches. Okay, so we are using the toggle switches. Okay, so thank you for watching the video.